Hi, hello everyone. Today I am going to deliver a lecture series on buck converter inductor design and capacitor design and what are their inductive ripples as well as capacitive ripples. Everything we are going to see now. Now, before that, buck converter design, as we know that what are the things are required for designing the buck converter? We require one switch. That is, let us talk about one switch, and another thing is one inductor, and another one is one capacitor. These three major elements are required for designing of the buck converter circuit. So now we'll see step by step what is the importance of inductor. So as we know that when we are going to design an inductor, let us talk about first we will draw the circuit diagram. Then after that we'll see what is the importance of each circuit and each inductor values as well as how we are going to draw the equivalent circuit also we'll see now. First we know that basic fundamental circuit is fundamental circuit. So fundamental circuit. Let us draw the fundamental circuit. As we know that this is the fundamental circuit. There will be a one source, and after that there will be a one MOSFET. Let us consider as a MOSFET here, and after that there will be a diode. We have to indicate here. Now after that, let us talk about this is plus minus. This is VDC and this is the gate terminal. Why I am drawing again this diagram, because we need to indicate the current direction, then only we can evaluate the inductor values. Now this is current direction ID and this is the current direction I switch. And next what we have to take it as a inductor. Let us take it as a inductor VL and inductor current IL. Let us take it as this is plus minus, this is plus minus, this is plus minus, and after that there will be a capacitor. So this is the capacitor. Let us talk about the plus minus. The current flowing through this is IC, and here next we are going to take it as a resistor. Let us take it as a one resistor, that is called R naught, and current flowing through this I naught. So this is the fundamental circuit. Now we are going to draw the equivalent circuits. When the switch is on, equivalent circuit, we will see how we are going to draw the equivalent circuit. When the switch is on, how? Then when the switch is on, this should be short circuited. Then the equivalent circuit will be, let us think that we'll draw with the different diagrams. So that you people can understand simplicity of each equivalent circuit. Now we'll draw equivalent circuit of the switch on condition. First, foremost thing is when it is going to be equivalent circuit, let us draw a voltage source, and after that it is a short circuited, right? Then that is this is the short circuited, and the equivalent circuit will be this is the diode will be open circuited. So we no need to draw the equivalent circuit. We no need to draw the diode symbols in this equivalent circuit. Then finally we are going to take it as an inductor. Then after that we will take it as a capacitor. Then after that finally we will take it as a resistor. So this is the equivalent circuit of the buck converter circuit under switch on condition. This is plus minus and this is the I switch, and after that here ID it is 0. ID is equal to 0, and let us talk about the inductor L, that is let us take it as a IL. We will take it here. Now after that what we are going to do here, we will take it as a VL, that is plus minus, and after that plus minus this is VC, and this will be IC, and this will be I naught, and this will be R naught. Let us take it as a this is VR naught. So when the switch is on, this is the equivalent circuit. Now from this equivalent circuit, we have to write some conditions. That is, first thing is short circuit means I switch is equal to 0. That is equation number 1. Then I switch is equal to IL. That is equation number 2. So next, what is the equation next? VD is equal to VI VDC. Input voltage. That is equation number 3. Next, ID is equal to 0. That is equation number 4. So these are the four major equations which we have to observe under switch on condition. Now we have to think about when it is switch on condition, we have to derive the inductor. So we need to derive when the switch on condition, when the switch is on, we need to derive the inductor value. Inductor we have to derive. Inductor derivation we'll see now. When the switch is on, what is the condition? Apply the Kirchhoff voltage law. Then minus VDC plus VL plus V naught is equal to 0. This condition we know. Now, what we have to write? VL is equal to VDC minus V naught. Let us take it as a here. For this condition, let us talk about this is number 1. Let us talk about this is number 2. Now, as we know that delta IL from the waveforms previous class which we have discussed, delta IL it is nothing but I maxima minus I minima. This is, let us take it as equation number 3. Now, this is switch on condition, then that is the, what is the formula? L into delta IL is divided by T on, then VDC minus V naught. Let us take it as equation number 4. Then after that, what is delta IL here? I maxima minus I minima. Then L into delta IL, well, let us take it as a delta IL will be one side, another thing will be another side we will take VDC minus V naught. Let us take it as this is equation number 5. Then delta IL it is nothing but what is delta IL? How we can write it here? VDC minus V naught is divided by L. Let us take it as equation number 6. So this is under T on condition. So here what we have to write here VDC minus V naught it is nothing but T on. From this equation, we know that what is the condition T on is equal to D times of Ts. So this is the condition we have to see, check. That is equation number 7. Now substitute equation number 7 in 6, then delta IL is equal to VDC minus V naught is divided by L into D times of Ts. So this is the equation number 8. So now what is the formula we are getting here? Delta IL. First, this is the ripple current at the time of, what is this? At the time of switch on condition. Now this is the delta IL current, which is VDC minus V naught is divided by L into D times of Ts. So this is the thing we have calculated now. Now we'll see under switch off condition how we are going to derive the inductor formula, inductor ripple formula. Under, now the condition is under switch is off. Under switch is off, inductor derivation will be inductor derivation. Inductor derivation is, let us talk about, as we know that from the circuit, first we have to take it as a equivalent circuit, then only we can derive this L value. So under switch off condition, let us derive the equivalent circuit under switch off condition. What is the equivalent circuit here? Equivalent circuit is represented as, this is the source. This will be completely switch off, means this is completely removed from the source, and here the diode is short circuited. That thing we have to represent here. That is the current direction ID. And after that, there is a inductor here. Then after that, there is a capacitor over here. Then after that, there will be a, what is here? Let is this is L. This is take it as a VL, and this is take it as a IC, and this is take it as a resistor R naught. So this is the overall equivalent circuit under switch off condition. From the switch off condition, how we can write it the things we will see now. Now first condition we will check. Now when the switch is off, what is happening here? I switch current it is 0. Next, what is the condition here? IL current it is nothing but ID. So let us take it as this is equation number 1 and this is equation number 2. Now coming to that, next, what is here? What is happening here? We here, VD, it is nothing but 0 because diode is going to be switch on condition. Let us take it as VD 0. Now, what is the switch voltage? V switch is equal to VDC. That is, take it as equation number 4. So, these are the fundamental concepts which we have derived from the equivalent circuit of the buck converter circuit. Now, we'll see how buck converter circuit will behave with the help of Kirchhoff voltage law and will derive the current equation. Now, when we are going to derive the buck converter current ripple direction, first we have to observe that minus plus VL, that is equal to minus V naught. Now, this is the major thing. That is why I am taking here equation number 1. Now, as we know that here also we have to write delta IL is equal to I maxima minus I minima. Let us take it as this is equation number 2. Now, what is VL? VL is equal to minus V naught is equal to minus L into, because here, let us first I'll come to know that, then you people will realize what I am going to draw. Here, when we are going to derive the current, that will be uh, last value to first value. Then that is the case under switch off condition. The delta change of current will be I minima minus I maxima is divided by, that is called T of condition. Here we need to take it as a delta IL. It is nothing but I maxima minus I minima. Then that is the case. VL is equal to minus V naught is equal to minus times of L into delta IL is divided by T of. So this minus minus will get cancelled. Then that is the case. What we have to write finally here? Let us take it as this is equation number 3 and this is equation number 4. Now, delta IL from this equation, delta IL, it is nothing but V naught into T times of is divided by, what we have to write it here? L. That is the formula. We have to write it over here when we are going to derive the first delta IL into L. We need to write it T of V naught into T of, so is divided by L. That is the formula which we have to write it in this condition, and from that we are going to derive the what is the output value, what is the input value, everything we will see. So now, see this case, we have to think that this is the final condition, equation number 5. Under switch on condition, switch off condition, delta IL, if we equate it, then we will derive the voltage gain of the circuit. Now, first we have to talk about steady state condition of the buck converter. Steady state, for deriving voltage gain, we have to take, when we are going to derive any power converter voltage gain, we need to talk about steady state condition of the DC to DC circuit. Steady state condition, what is steady state condition? We will see now. First, before going to see the steady state condition, when the power converter must and should have some assumption. What are those assumptions? First, foremost assumption is all the power converter circuits are ideal. It is nothing but internal resistance of the capacitor, internal resistance of the inductors, all are equal to 0. Now, selected inductor and capacitor values are much higher values than inductor will help for providing the constant output current, capacitor will help the providing the constant output voltage. Now, third assumption is here buck converter means input will be very high, output will be less. Now, next, fourth assumption will be whatever the source power it is there, that should be equal to the load power. P source is equal to P load power. Now, after that, we have to take it as this is the resistive load condition. That is the case. I naught is equal to V naught by R. We have to take. Now, what is the any power converter? What is the duty cycle ratio? 0 less than D less than 1. So these are the basic conditions we have to assume. Then only we will observe that what is the voltage gain. Now, under steady state condition, let us talk about inductor ripple current delta IL is equal to, this is under T on condition. Now delta IL, this is under T off condition. So if we equate both the things, what will happen here? We'll see now. First T1 condition VDC minus V naught into how we written here T on is divided by L, that is equal to next L into delta. So how can we write it here? L into delta IL. So we have to write delta I, right? Then that is the case. Delta I is equal to what we have to write here. 1 minute. I'll erase it. Then after that we go for the delta IL formula. So under switch off condition, what is the delta IL? Delta IL, it is nothing under switch off condition. What is delta IL? Delta IL, it is nothing but V naught into T of V naught into T of is divided by V naught into T of is divided by L. So this is the equating on both the side L is going to get cancelled. Now VDC minus V naught Tn it is nothing but D times of Ts. Next V naught into T of it is nothing but 1 minus D times of Ts. So this when we will derive it, Ts will get cancelled. Then how can we write it here? VDC D times minus V naught D times that is equal to V naught minus D times of V naught. This one will get cancelled. Then what is the output voltage? Finally, we derived the voltage gain. That is output voltage V naught is equal to D times of VDC. And finally, we will write the voltage gain. That is equal to, what is the voltage gain here? We are going to write it here. Voltage gain V naught by VDC. That is equal to D. This is the final derivation for the voltage gain circuit. Now from this, we have to derive the inductor value. What is the inductor value? I written that. What is the inductor value from the delta IL under T on condition? How we can write it here? Delta IL that is equal to VDC minus V naught, that is T on is divided by L. Next delta IL under switch off condition. How can we write it here? Delta IL is equal to V naught into T of is divided by what we have to write here? Divided by L. Now we will take it as a T on as well as T off. First we will take it as a both the sides. What is T on? What is T off? Everything we come to know that. Then only we can derive the fundamental things what we have observed. Now what is T on value here? T on is equal to what we have to write L into delta IL is divided by what is that? L into delta L is divided by VDC minus V naught. Now here what is T of? T of is equal to L into delta IL is divided by what we have to write? That is V naught. So now what is the total time derivation? These are the, let us assume that this will be equation number 1, this will be equation number 2, and this will be equation number 3, and this will be equation number 4. Now, from this, we come to know that total time value T is equal to T on plus T off is equal to, how can we write it here? T on it is nothing but L into delta IL is divided by VDC minus V naught. Next plus L into delta IL is divided by V naught. This is the first part of the derivation. This is the second part of the derivation. Now, how can we write it here? Take it as a common. Then T is equal to, how can we write it here? Let us take it as a T is equal to, total time T is equal to T on plus T off, that is L into delta IL. We will take it as an outside. Then how can we write it here? So VDC minus V naught VDC minus V naught plus V naught is divided by, how can we write it here? V naught into VDC minus V naught. This is the derivation we will get it. Now, as we know that from the previous derivation, what is the, here V naught will get cancelled. Then what we will get it here finally? L into delta IL into VDC is divided by V naught VDC minus V naught, it will come. Now, if we observe that, before going to that, let us take it as a VDC L into delta IL, that we are going to take it as a V naught minus VDC minus V naught. Now, as we know that, so first foremost thing is this is the time value. As we know that time, it is nothing but switching frequency 1 by F. So that we will substitute it in that one. Then 1 by F is equal to L into delta IL into VDC is divided by V naught minus VDC minus V naught. Now let us talk about final derivation, that is L is equal to F. L will be in terms of, we will write it in terms of alpha. How we are going to write it now, check it. We will see now. So first, foremost thing is when we are going to see that from that equation, delta IL, it is nothing but delta IL is equal to V naught into VDC minus V naught is divided by F into L into VDC. So here V naught is equal to alpha times, that is, otherwise we'll take it as a duty cycle also, that we have to take it. So either alpha or D, it is nothing but duty value. So here when we are going to substitute this value in this one delta IL, then delta IL it is equal to V naught is not alpha into VDC. Now take it as a VDC, that what is V naught? Alpha times of VDC. Now let us talk about F into L now into VDC. So this VDC will get cancelled. Then finally, how can we write it here? Delta IL is equal to alpha into 1 minus alpha into VDC is divided by F into L. This is the ripple current, peak to peak ripple for the whatever the buck converter we are using, that is the peak ripple. And from this, how can we write it here? So I maxima minus I minima, that is equal to delta IL. Suppose we need I maxima, means I maxima is equal to delta IL times plus I minima. This is the another equation. Suppose if we need I minima, means I minima is equal to, how can we write it? I minima is equal to delta I minima, how can we write it here? I minus delta I plus I maxima, like that we have to write. So these are the basic derivations which we have derived now. Now we will see what is the inductor value. Final inductor value, how we will derive here? So L is equal to final inductor. What is that final equation? We will write it here. Inductor L is equal to delta I, inductor L is equal to what we can write here? Alpha 1 minus alpha VDC is divided by what we can write it here? Frequency into delta I. This is the inductor formula for the buck converter circuit. Now coming to the capacitor derivation. Now we will derive the capacitor. Now capacitor, how we will derive? First foremost thing is peak to peak capacitor ripples. Peak to peak capacitor ripple. We have to see, then that one, then only we'll derive the capacitor value. Peak to peak capacitor ripple derivation we have to see. First foremost thing is from the equations, from the waveforms, delta Q is equal to half times of delta I is divided by 2 into T by 2. So then delta Q, how can we write it here? Delta Q, it is equal to delta I is divided by 8 times of frequency. So as we know that what is delta, what is that? Delta V, it is equal to delta Q by C. Then how can we write it here? Delta I is divided by 8 times of F into C. This is the formula for the peak to peak ripple for the buck converter circuit. From this, how can we write it the capacitor formula? So from this, how can we write it capacitor formula? C is equal to how delta I is divided by C is equal to, how can we write it here? 8 times of F into what we can write it here? Delta V. This is the overall formula for the capacitor design of the buck converter circuit. Now from this, we have to observe that capacitor value, inductor value, voltage ripple, capacitor ripple, everything is available. Now we will check one problem. We'll solve one problem on these formulas. We'll see for the buck converter circuit. Now let us talk about the problem. This is the problem. That is why I'll take it as a one numerical. So let us take it as a one problem. I'll read it that one, and now we will see how the problem will be solved. Let us take it as a buck converter. A buck converter. Given problem. A buck converter. A buck converter. A buck converter as shown in figure A below is working is working in working in steady state condition is working in steady state condition is working in steady state condition. The output voltage the output voltage the output voltage and and inductor current inductor current can be assumed as to be ripple free, assumed as to be ripple free, ripple free. Figure B, figure B shows the figure B shows the inductor voltage waveform, voltage, inductor voltage waveform, inductor voltage waveform. Then calculate the then calculate the duty cycle of the circuit. Now we'll see what are these. This is the theory he has given. Then we'll see the circuit. First, we know that buck converter circuit. What is the circuit he given? This is the buck converter circuit, and this is the switch he is given here. And next, what is that? What is that? This is after diode. We will take it as a diode next. Then after that, this is VDC. This is plus minus. This is diode. This is anode, and this is cathode. And after that, there will be an inductor, and after that, there will be a capacitor. Those things we have to observe here. Whatever the problem he given, VL, VC. Next, we will take it as a resistive load, that is R0. And he given in one more thing, he given the output voltage waveform. That is, this is the waveform. Let us draw the waveform. This is the T on condition. This is T off condition. That is the thing he given here. Let us take it as a this is T on, and this will be T off. So then, what is the voltage here? Plus 30 volts he given here. Minus 20 volts he given here. And this is what is this? This is the total time derivation. So this is the problem he is given for the one of the competitive examination. Now we'll see. So as we know that first foremost thing is we have to remember that what is the switch on condition? What is the switch on condition? We'll see now. Under switch on condition, we know that what is the formula? VL on under switch on condition, VL on is equal to VDC minus V0. Then what is the under V on condition? What is the voltage here? He mentioned that clearly. That is 30 volts. That is VDC minus V0. Now next, let us take it as a this is equation number 1. From the waveform under switch off condition, what is the voltage? 20 volts. That is equal to minus V0. Here discharge means we will take it as a minus 20 minus minus will get cancelled. Then equation 2. Then from 1 and 2, what we can write it here? VDC, that is VDC is equal to, how we can write it here? 30 plus 20, that is from equation 1. Then what is VDC? VDC is equal to 50 volts. So we know in output voltage we know, input voltage we know. Then how we can go through the things? Suppose you people have a confusion, you can write in a different manner. That is equal to Directly you can draw from these waveforms. How? So 30 is equal to VDC minus what is the V naught voltage? As I told you that what is the V naught? This is 20 volts. That is VDC is equal to 30 plus 20. That only I written here. Again, I am writing here. Then what is the output? As per voltage gain formula, what is the voltage gain? What is the voltage gain? Voltage gain, that is nothing but V naught by VDC, that is equal to duty cycle. So in the problem, what he is asking, duty cycle only. Then how we can write it here? Duty cycle is equal to what is the V naught? That is 20 is divided by 50. 0 will get cancelled. What is the duty cycle here? 0.4. So this is the all over about buck converter circuit. Next class we will see how boost converter will operate and what are the inductor capacitor design values we'll see. Thank you all. Have a good day.